Space Station Freedom, the year 2000. Position 200 miles above the Indian Ocean. It is home for 60 specialists working in 6-month shifts. They will manufacture goods in zero gravity, products that could only be made here in the pure, frictionless conditions of space. Their eyes will constantly monitor the Earth below, where pollution is threatening. And some space workers will turn their instruments outward toward the universe to plot the course to the planets and beyond. In this space year 2000, the key to being able to live and work in space will be traced not only to the technological marvels of NASA, but to a country road in Alabama.
Major funding for the new explorers is provided by Amoco, celebrating the adventure of scientific discovery for the year 2000 and beyond. Additional funding is made possible by Waste Management Incorporated, providing recycling and other waste services around the world.
Hello, I'm Bill Curtis. A trip to Mars will take 6 months to a year, and it represents a new frontier, living in space for long periods of time. Some answers to that challenge will be found here at NASA, in this biomass production chamber, where scientists are studying an environment that will provide air, food, and water for long durations in space. It may look space age, but the seeds were planted before the turn of the century, when one man studying one crop, the sweet potato, laid a foundation for the exploration of outer space. In the highlands of east central Alabama, Tuskegee University rests quietly, its winter break. The buildings are empty except for the history they hold. A century ago, students raised the walls of their own classrooms with bricks they made themselves. It's a small part of the storied past at this institution. Tuskegee stands as a monument to its founder, Booker T. Washington, and its beloved teacher, George Washington Carver. Both men seem strongly in attendance here. Their spirit pervades the campus, as if their knowledge continues to have an energy of its own.
Today, earlier, the NASA team had a meeting, and some very interesting data was presented.
Dr. Walter Hill, just like Dr. Carver before him, is studying the sweet potato. He leads a team of 20 scientists, specialists who represent an array of disciplines from nutrition to genetics. They've come together to focus their efforts, aiming for the stars. They are examining the sweet potato under every condition imaginable: increased light and heat, more carbon dioxide, trying to grow it even without soil, exploring all the possibilities to find just the right combination that will work here in space, to provide the food that will take future generations on voyages that may last lifetimes. The journey to Mars begins here in Tuskegee's greenhouse.
8 crops were initially selected by NASA for study. Among these, sweet potato. And sweet potato rated very high among these crops for several reasons. One, you can eat both the foliage and the roots. The foliage provides a very nutritious vegetable such as similar to spinach or greens. And then, of course, the roots provide a tremendous carbohydrate as well as a balance of other nutrients.
How many of you eat sweet potatoes? Well, good.
At Tuskegee Public School, tomorrow's astronauts will need to know about survival in space. They get a briefing during a visit from team member Jill Hill, Walter's wife.
Who will be going up in space? Yes, sir.
We.
Say that loud.
We.
We, meaning, yes, you all. Because by that time, you will be adults, okay? Who knows, has any idea what they want to do when they grow up? Archaeologists? Well, since they don't know what's there, they'll probably do a lot of digging to find out what's up there, right? So they're going to need you to go. Yes, ma'am, what are you going to be?
Teacher.
A teacher. We know that they're going to need teachers up there, okay?
There is another scientist never far from the research group. None of their work would have been possible without the genius of George Washington Carver. A brilliant mind, a wealth of talent. The great scientist earned the world's respect, yet his life began in slavery during the Civil War. The youngster's childhood was shaped by the love of learning and the struggle for freedom. With his mother and sister, George was kidnapped from his Missouri home and sold in Arkansas. He alone was found and returned. Nature was not just a playground, but a private classroom. There, he taught himself to paint and to weave. He studied the plants themselves. Education for Carver was a journey. By 1885, he finished high school, but most colleges then were closed to Negroes. Within a year, though, he was accepted to Simpson College in Iowa, soon transferring to Iowa State, where he became the school's first black graduate and eventually its first black teacher. Carver's talents blossomed. His early paintings earned him a prize at Chicago's Columbian Exposition in 1893 and fueled his ambitions as an artist. But agriculture won out, and science remained his greatest avenue of self-expression. As the current dean of Tuskegee's School of Agriculture and Home Economics, Walter helps to carry on the work begun by his famous predecessor. He knows Carver's story well. It seems like Carver was so talented, he would have surfaced anywhere. But it was a hard road.
Well, look at it as part of God's plan, perhaps. He sprinkles genius in many places, and so it was perhaps inevitable that Carver's talents would be manifested. And perhaps the road that he traveled to get there, to get to the point where he could share this with the world, makes him unique. Of course, it led to Tuskegee.
How did he get to Tuskegee? Did Booker T. Washington recruit him?
He did pursue Carver and convinced him for moral reasons. The fact that he could really contribute to the life and development of African American people. That really was the major turning point in the decision for Carver to come to Tuskegee.
Today at Tuskegee, Carver's early work is being brought up to date. It's harvest time inside the greenhouse, a plant laboratory filled with a hardy crop. It's a harvest of sweet potatoes and data. Here, in an adjoining growth chamber, these young sweet potato plants are part of an experiment. These plants have been receiving a fresh supply of nutrients every 2 days. That's a lot of food compared to their normal schedule. In 3 weeks, we'll visit this chamber again to determine just which nutrient treatment will be best for plants grown in chambers up in space. But there's another complication when farming beyond Earth's atmosphere.
When I'm here on Earth, if I jump up, I come down. If I throw up soil, it'll come down. There's gravity that is pulling us down. In a spaceship, if I jump up, my head hits the ceiling and I bump it. I'm not a happy person. If I throw soil up, it's just going everywhere, okay? So soil will make a major mess. So we have to learn how to grow plants without soil. And that's what we have done at Tuskegee with the sweet potato.
To solve the problem, the team turned to a hydroponic system called the nutrient film technique, the process of growing plants with a thin film of liquid nutrients and no soil.
Let's bring the whole vine over. And do you see any sweet potatoes? Yes. How do they look? They're big, huh? They're big. They're big. Okay, so they've been growing a long time.
Hydroponics has been around since the days of Carver, but these scientists were the first to apply the technology to a root crop that grows underground. That breakthrough earned the team a patent, and much of the credit goes to material specialist Dr. Carlton Morris.
Once the solution goes through the system, it starts to flow. The roots actually pick up the solution as well as water.
So I now see the film or the water carrying the nutrients. Once you have the film, where does the plant go then? Right on top of it?
In order for us to plant, we need a system for holding the plants in place, and we have a special holder that we use. It's called a pressure plate to hold the plants in place.
I see, right down in there.
Yes.
To hold their roots, I presume, right in the spot where they can pick up that nutrient.
Exactly. And this is what's unique. This is the vinyl or plastic that we use with the system. The black side goes to the inside, and the reason for that is to keep the light out of the channel, out of the area where the root systems are growing. And basically, we can just put it on the table, and then we fold it back.
And then an anchor to kind of keep it in place?
Right. We anchor it. That provides the basic pressure plate. And
now we take it over?
Now we can take it over. And this is basically the plant anchor system. And what we do is we cut a small slit in the hole.
And that's where this little cutting will go?
Exactly. Actually, within 48 hours, you can see the roots developing there.
Really? Starting to grow?
They will start to sprout and actually grow. It's just a matter of taking small cutting and just inserting it in the hole.
Planted. So this would become a matter of life and death to an astronaut. This would be his lifeline to being able to survive. Carlton, what do you think Dr. Carver would have said if he saw this?
I think that Dr. Carver probably would have smiled. And being the person of vision that he was, I think he would be one to just fall right in and say, what's the next step?
Let's go.
Let's continue.
Let's go to space. If he did, Carver would find a unique set of challenges. The first is a confined work area where every inch is planned and guarded. The growing area to support a year-long mission would be confined to a chamber in one part of the space station, designed much like this, in a circular configuration, so one astronaut could tend to the crops. This biochamber at Cape Kennedy is part of the space agency's CELS program, the Controlled Ecological Life Support System. It has enough growing room to support one astronaut for several months. So far, NASA has loaded the chamber with a number of staples. Not long ago, wheat was nurtured and harvested, a viable protein source. The soybean also has fared well. And soon, NASA will start with another plant, seeking the expertise of Walter Hill and Company. With the sweet potato and hydroponics, Tuskegee has broken new ground with no ground at all. Walter, I understand the principle of the film technique, and I know that water is running under there, but gravity holds it all in. So what happens in the space shuttle or a spaceship when you don't have gravity to hold it down and the water can go everywhere?
Okay, there are many approaches to this. Let's look at one. These are our plants, and as they grow, they'll grow a root that'll come out here, grow along the surface, and as the plant needs moisture, there's a suction or a negative pressure that the plant will utilize in causing water to come up through the cells into the plant.
Almost. So the moisture can come through the middle. Oh, yes, I see. Yes, it seeps or is sucked right up through.
That's right.
With or without a metal membrane, nutrient film is an essential part of hydroponics. But space agriculture might still call for some type of soil. Now, over here, nothing could grow in there. No, don't tell me you're growing things in there.
You know, this is what people are most commonly used to. If I stick a plant in here, it'll grow. This is like planting in your backyard or in a sandbox, very common. And this is one school of thought that may occur on the moon or on Mars. Instead of a system like this, we may actually be able to grind up some lunar surface, some Mars surface.
Create our own soil.
Create our own, quotes, lunar soil or Mars soil, add special kinds of nutrients to it. And we may be able to farm similarly as we do on Earth.
Well, that would give you, for a colony on the moon or on Mars, a lot of food that you would need for a lot of people. And of course, when you're living there, either in a space lab or in a colony, you'll one day be recycling everything, including carbon dioxide, oxygen, our own waste. So nothing would be, and maybe that's a good way to live on Earth.
I think that's the real secret. I think in the process of doing this work, we're going to really learn how to be better stewards for our planet.
That, of course, could come right from the teachings of Dr. Carver. At Tuskegee, he used and reused everything. From the peanut, he developed 300 products, among them cheese, coffee, plastics, and medicinal oils. And from the sweet potato, 118 products, including molasses, rubber, ink, and glue. But Carver's work was never confined to the laboratory. Perhaps his greatest invention was his movable school. With it, he would travel the South and teach farmers to plow deep, add fertilizer, rotate their crops, and plant peanuts to restore nitrogen to the soil. For Carver, the goal of science was service. From his own early struggle, he gained a sense of purpose, a concern for the unfortunate, and a desire to share his knowledge with them. Was he ever bitter about those early circumstances?
You read about him, you look at his work, and clearly he was a person who was able to direct the pain and the struggles that he had in his early life into concrete and constructive work. And what's great about it is that he was able to really draw on his creative powers that perhaps in some ways were shaped by those hard circumstances, and then turn those into useful products, into great science, and certainly into great education for African Americans.
And the tradition of outreach is as strong as ever. This is the Center for Research on Diet, Lifestyle, and Cardiovascular Disease, where nutritionists are investigating the sweet potato's impact on cholesterol. In the South and across the country, the African American community suffers from unusually high cholesterol levels and the related risks of heart disease. Here, 40 participants eat 3 meals a day for 8 weeks, and they have a special ingredient: sweet potato greens.
Since you've been on this diet, do you feel better?
I feel a lot better. And I think I'm going to really stick with the diet even after the program is over.
It's the tips of the potato's vines that contain omega-3 fatty acids, which can lower total cholesterol levels. In this experiment, participants have been placed on a highly controlled diet with 30% of calories coming from fat. As a side dish, sweet potato greens are served with each meal every day. Now approaching the study's end, indications are promising.
My cholesterol was 300 and I believe it was 87 when I started. And since I've been on the program, as a result, now it was down to 180. And that's way down. Couldn't wait to get to my doctor to show it to him.
Led by Dr. Ralphinia Pace, the cholesterol study is the first of its kind performed at a major black institution. Pace hopes it will help to reduce cardiovascular disease in the region, the state, and ultimately the nation.
This evening is very special to me, and perhaps I'm sounding very emotional. And that's because I really, sincerely mean it from the bottom of my heart that we appreciate the commitment that you have made by participating in this research. I think we said to you early on as you started that you would be making history. You have succeeded very well in doing that.
It's one thing to prove the benefits of eating sweet potato greens. It's also important to spread the word. The volunteers will teach proper diet and nutrition to friends and relatives in Tuskegee and 10 other communities in Macon County, Alabama. Lunchtime at a nearby restaurant tells the story well. Fried foods, saturated fat, and cholesterol, the leading contributor to cardiovascular problems. The volunteers will recommend removing the skin from chicken, baking instead of frying, and sweet potato green tips cooked in a teaspoon of soybean oil. In one form or another, the sweet potato seems to pop up everywhere. Research in the Hills Kitchen focuses on refinement of the sweet potato cookie, a family favorite. It's also a secret recipe.
Okay, don't let me shoot now. Take the ball from me. 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 Take the ball. Take the ball. This ball. Okay, I'm shooting. Uh-oh, Daddy made one. Okay, let's see what you can do.
Another common thread for Walter is his interest in the growth of those around him, whether as children or the emerging scientists at work.
As we develop science and innovations in science, and particularly those that may benefit humankind, it's very important for me to be able to share that, particularly with young people. The fact that as a scientist, it gives me an entree to young people, whether they're in the 4th grade, 7th grade, 9th grade, 12th grade, allows me the opportunity to get before them or with them, along with my colleagues, and create excitement in them. And really, that's where the future is. I mean, the future is in those young people who are turned on, some of whom are in this lab, for example, and who are at a young age even creating things that are going to help human beings in the long run.
The young members of the Cells Project are using genetics to improve the sweet potato. By introducing foreign genes into the potato, perhaps even from different plant species, they hope to make the sweet potato more nutritious, more resistant to disease and to extreme temperatures. The improved sweet potato could also greatly help developing nations where farming is difficult. Biotechnology of this nature is making steady progress and has produced some intriguing studies, as Dr. C.S. Prakash explains.
Some of those research is just of basic academic interest, trying to learn how an animal gene is different from a plant gene. But some of the others also have a very practical interest. For example, a gene has been cloned from an Arctic flounder in Alaska and has been introduced into the plants. And this flounder secretes a protein that protects itself against extreme sub-zero temperatures. So by expressing that gene and hopefully making it work, one day you might be able to grow bananas in Minnesota. You see, and that's the whole goal. I mean, some of them are just curiosity. That's what drives the science. But down the road, you know, you might have a spin-off of huge practical interest.
One way to genetically alter the sweet potato is with the gene gun. First, foreign DNA is mixed with tungsten. These microbullets are then placed on filament discs and loaded into the gene gun chamber, along with sweet potato leaf clippings. Riding with the tungsten, the DNA blasts its way onto the plant. The foreign genes penetrate the cell and settle into the plant chromosomes. The new genetic makeup will continually appear as the cells divide. The gene gun technique is in the early stages of development.
Once we have learned how to introduce genes into sweet potato and how these genes are expressed, our goal then is to see if we can use this knowledge and use this technique to improve the sweet potato's productivity, particularly in developing countries.
While genetic engineers work from the inside out, nutrition scientists take the reverse approach. Remember these young plants on their nutrient binge? These are the same vines just 3 weeks later. They look like Jack's beanstalk. This looks like an enormous growth.
Yeah, definitely. And these plants, I'm in the 4th solution, so technically it's in the 8th week.
Really?
8th week of growth, and we get tremendous foliage yield from this treatment where we change the solution every 2 days.
I can imagine up in the space lab, they'd grow right out of the space lab if you didn't eat them.
Yes, definitely. And but whether we're going to need this foliage, this much foliage, I don't know.
If a plant grows best during the daylight, why don't you just leave the lights on all the time?
Well, we have done that, but Some varieties like that very much, some don't. We find that with this cultivar in particular, when it's under light all the time, we get a lot of stunting of growth, no storage root production.
Really? So that they have adapted to a light cycle outside with night, perhaps to rest.
Exactly.
To take that energy for the growth.
For the growth. And you put it right when you say rest, because when you look on them under continuous light, they look so tired and droopy that they really need some rest. Yeah. So
to get going. But if you treat them properly, look at this.
Right.
What we want to remember is that all of this really started with Dr. George Washington Carver. He was a scientist who liked to study plants and many other things.
The goals of George Washington Carver to improve the lives of those in the rural South are being fulfilled by a team of scientists carrying his legacy, not only for Alabama, but in developing countries of the world to fight global hunger and provide for our future in space. We've seen what it takes to leave the Earth behind, put astronauts in space and keep them there. We've seen the seeds of science grow to great heights. Dr. Carver might say, follow your curiosity. You never know where science might lead.
Major funding for the New Explorers is provided by Amoco, celebrating the adventure of scientific discovery for the year 2000 and beyond. Additional funding is made possible by Waste Management Incorporated, providing recycling and other waste services around the world.
A video cassette and accompanying teacher's guide are available for each episode of The New Explorers. To order, call 1-800-621-0660 or write The New Explorers, General Learning Corporation, 60 Revere Drive, Northbrook, Illinois, 60062.
This is PBS.